I have already reported on the 16th flight in this video and didn't think much of it, just a nominal flight. But with the new black and white pictures and color pictures, there are a few things to unpack. First, some context. Here is the 16th and 15th flight paths and landings. That's the end of context. Here are some issues I have with the 16th flight. Issue 1. The navigation images look a bit janky, but that is due to the fact that winter is coming. This in turn decreases the density of the air, and in turn the team is forced to increase rotations of the rotor blades to compensate. The team tries to find the right speed with which to take black and white images, but that's still a trial and error. For example, during flight 13, the landing was captured with much higher frame rate than other maneuvers in the same flight. Caused me a headache to synchronize the Perseverance color footage with black and white images from Ingenuity. Link to my headache-causing video in the upper right corner. Second issue. Part of the black and white video is missing. To be more specific, the part which would show this section of the journey, here in red. This is typical because Ingenuity is sharing its data traffic with the Perseverance rover. The images from the Perseverance rover have a higher priority. Issue 3. The Ingenuity team was supposed to take 9 color pictures during its 16th flight. Right now we have 10. 1 pre-takeoff and 9 during the flight. And this brings me to my issue. Why at all take this color picture while on the ground, on Sol 263? That is 9 days after Flight 15 has been completed. That is most unusual. They do take black and white pictures of the ground, but only if there is a time gap of 2 to 3 weeks between the landing and the takeoff, like during solar conjunction. They use those images of the ground to count the changes in the sand distribution. Simply put, to see the sand move before and after some extended period of time. The same goes for some color images. For example, just before its first flight, Ingenuity took a series of color images for the same reason, to look for changes in the sand. But between 15th landing and 16th takeoff, there was only one color picture taken. No other color images of the ground were shot. There is no before and no after to compare. But the second reason to take a color image of the ground is more interesting. A suspected emergency. An example would be this color image taken 3 weeks after 13th flight and 28 days before the 14th flight. It was taken on Sol 214, next to a sand ripple. The team had to be sure the chopper doesn't hit any rocks while experimenting with higher rotor speed rotations. Issue 4. On closer inspection, I did notice something strange in the ground color image. Some of the stones are in the wrong position. They are too upright, like these ones, and some are not buried in the sand. There seems to be a slight color change right here. Now let's put all 3 facts together. NASA took an unplanned color picture of the ground and put a priority on it as it was being before other color images. Probably they suspected to see something. 2. Some stones seem to be turned over. 3. Some part of the land seems to be disturbed. The logical conclusion would be that Ingenuity had some problems while landing on the previous 15th flight. Probably one of the legs, probably this one, touched the ground before other 3 legs did and started to shift. I think this leg landed here and shifted this direction and eventually buried itself here. But is there a way to prove it? Maybe. Let's take a look at pictures from the landing of the previous 15th flight and pictures right after 16th takeoff and compare the before and after. A quick reminder, the color camera captures images opposite to the position of this leg. This means we should see some drifting in the after pictures right here. and I'm sorry to say it, but it's inconclusive. The Ingenuity's shadow doesn't allow to see things clearly, so with the available information, I can't be sure. Does the Ingenuity team know? Yes, because they have more data, including gyroscope data, which would show if the helicopter moved after 15th flight's touchdown. While writing the script, this happened. NASA published this picture. This is a picture of 16th landing site. We know this because rocks below the navigation camera images are the same as in this color image. This image also features the ground, and it was taken 6 days after 16th flight landing and 7 days before the planned 17th flight. And what do you know? This time we see this leg is not in the landing hole. It is just outside of it, which either means drifting while landing or energetic bounce. So what are the reasons for these landing problems? Probably it's the change the team had to make to the rotor blade's rotation speed. The chopper either falls to the ground too fast, like in the 16th flight landing, and makes a dent, or probably drifts because by inertia the rotors keep spinning like during this 15th flight's landing. The drifting is more dangerous, as this might happen. The team didn't test on Earth this type of landing with higher rotation speeds, as Ingenuity was supposed to break a long time ago. So what is the solution? Maybe better diagnosis. If the team programs the chopper to take more black and white images during the landing, they might see more options of what to do. I think the limit they have is 10 frames per second. The maximum they have already tested on Mars was almost 7 frames per second during the 14th short 2-meter flight. Then the team might decide to land the helicopter more sideways, like this. I think they already tried this similar tactic during 13th flight, but I can't be certain. As I was editing this video, NASA announced that the 17th flight was successful, but has had some communication problems right during the landing. Now, some context. The chopper has a tiny multi-directional antenna, which sends signals to the Perseverance's base station antenna. This is different from the hexagonal antenna, which sends signals to Earth. There are two things in the way of direct communication between the rover and the helicopter. First is the 45 kg plutonium-238 oxide radioisotope thermoelectric power generator. So to mitigate this communication obstacle, the rover has to just turn around. The second obstacle is the geometry of the terrain itself. When the helicopter was landing on December the 5th, it landed on a radio communication blind spot. To mitigate this problem, all the team has to do is to wait till Perseverance again is in the direct line of sight. I wouldn't worry so much about this situation. We even have telemetry and 5 landing pictures. The telemetry shows that the solar panels are being charged in a nominal way. Thus the chopper itself is firmly in a horizontal position. Another proof that the flight was nominal are pictures themselves, as just before the 17th flight, Ingenuity's team told where the chopper will have landed, and that is exactly where it landed. These ripples indicate that the wind is blowing this way. Another interesting thing is that we have no information about the color pictures taken during the 17th flight. How many of them are planned and what are they going to feature? My guess is that because we have pictures taken of this area during flights 9 and 16, we have a gap in color images right here. But that is my speculation. Also, the Ingenuity's team announced that the 18th flight is going to be 200 meters long. The helicopter must reach at any cost this location and finally update its navigation software, because if the chopper is stuck here, Perseverance has to leave Ingenuity forever. Perseverance has a mission, and some pesky chopper, which I personally adore, is not going to stop it. And because you stayed watching this marvelous video for so long, here is a bonus for you. I realized that Flight 16 and 9 have almost identical trajectories, and color camera in both flights was pointed in the same direction. So I created a series of pictures from both flights, meshed into one uninterrupted zoom out. Enjoy this bonus and have a great sol.